So this video lesson is all some extra practice about solving inequalities. Now these are solving basic inequalities, and this is solving and graphing basic inequalities. So not things that are terribly complicated, things along the line of x plus 12 is less than or equal to 9. So let's take a quick review of that. We'll do 2 more problems together as a review, and then I'll give you 6 problems at the end to work on. So x plus 12 is less than or equal to 9. Now, like an equation, the rules of inequalities say that we can add, subtract, multiply, or divide anything from either side of the inequality as long as we do the exact same thing to both sides. So if x plus 12 is less than or equal to 9, if we take that 12 away, we can find out those sets of numbers that make that equation true. Take away that 12, we have x. X is less than or equal to 9 minus 12, which is the same as 9 plus negative 12. Looking at that on a number line, we have 9. We're going back by 12, which means we have to pass 0. So we have 9 here. We have 3 units left to go. So 9 plus negative 12 is negative 3. So as long as the x that we choose is less than or equal to negative 3, that means that x plus 12 will be less than or equal to 9. And so now to graph it, we want to represent it on a number line. And in this case, the only number that we're really concerned about on the number line is negative 3. Because either x is going to be less than or equal to negative 3, or it's not going to be. So we have 2 different ways that we can represent our inequality on a number line. One is with a closed circle, which is a circle filled in. And the other is with an open circle. Now, as is suggested by the fact that the closed circle contains more stuff than the open circle does, a closed circle shows that this equal to condition of less than or equal to is part of the inequality. So if x is less than or equal to negative 3, it could actually be negative 3. So we use the closed circle to represent that negative 3 is a possibility. And now we want to shade in the half of the number line that shows where x is, and it is less than negative 3. Now, the easiest point to check on the number line is 0. 0 is here. Is 0 less than or equal to negative 3? No, negative 3 is less than 0. So 0 is not part of the solution, and so all of those numbers on the more negative side of the number line, that is all those numbers, remember the more negative that you get, the numbers get lesser rather than greater, so that is the side of the number line we shade in, and this is the solution and graph for x is less than or equal to negative 3. Let's take a look at that. On a different example, 4x is greater than negative 12. So we want to take a number x, multiply it by 4, and have it be greater than negative 12. So it could be any positive number, but it could also be any negative number that's bigger than negative 12. Well, to find out what x is, let's get rid of this 4. So if we divide x by 4, or 4x by 4, we get x is greater than, because this number is positive. For multiplication and division, we'll get back to that in a second, is greater than negative 12 divided by 4. Negative 12 divided by 4, well, 12 divided by 4 is 3, but we have a negative divided by a positive, which is a negative. So it should be negative 3. X is greater than negative 3. Now, writing that on a number line, again, the only number that we're really concerned with is negative 3. X is strictly greater than negative 3, so it can't actually be negative 3. If x were negative 3, then 4 times negative 3 would be negative 12, and negative 12 is actually not greater than negative 12. It's equal to negative 12. So x can't be negative 3. We're going to use an open circle to represent that negative 3 is that key point, but x actually can't be negative 3. And now on our number line, towards negative infinity is the less than side. Towards positive infinity are all those numbers greater than negative 3, so any number greater than negative 3 is one that can be used in this inequality. X is greater than negative 3. Now the one condition that I mentioned that throws a wrench into this a little bit could be multiplying or dividing by a negative number. And if we look at that on a number line from 0, we want to talk about absolute values, and our absolute values, our AVs, get bigger as we go towards the infinities. That is because absolute value is just the distance from 0. So a very, very large positive number or a very, very large negative number are both a long way from 0. So in some ways, the positive and negative numbers are opposites from each other in that, in many ways actually, but in that the farther you get from 0, the bigger the absolute value. So if we're multiplying something on the number line, like 2, multiplying it by -1, it's going to become -2. And -2 by -1 is going to become 2. Now, if we look at that in comparison to a number like 4, 4 times -1 is -4. But whereas 2 is less than 4, if we multiply both sides by -1, 2 times -1 is -2, 4 times -1 is -4, we can see on our number line, because our less than rules don't change on the number line, less than is always to the left, it's actually that -2 is greater than -4 in this case, and that's because we've switched the orders of our absolute values. Bigger absolute values is to the right on the number line in the positives, and to the left of the number line in the negatives. So when we multiply or divide by -1, we have to switch that sign around. So x divided by -3 is greater than 12. Multiply both sides by -3. Bring this down here a little bit. We get x. 12 times -3 is -36. But again, because -3 is negative, we have to flip that sign around, and it becomes x is less than -36. And so you can try a few numbers here if you want to, from greater than and less than -6. There's a 0, but really what we're interested in is -36. It is strictly less than, so it is just an open circle because it cannot include -36. 0 is not less than -36, so the arrow goes away from 0 or towards the lesser side of the number line. So with all that in mind, go ahead and pause the video lesson, work on these 6 problems. Let's label them 1, 2, 3, 4, 5, and 6. Pause the video lesson and come back unpaused when you're ready. So, I did not mention before, but if you have not graphed the solutions you've gotten for the inequality, go ahead and pause the video now and do that. Otherwise, let's go through the answers. X plus 12 is greater than 0. Subtract 12 from each side to leave just x. X is greater than -12. On a number line, -12 is the number that we're most interested in. It is an open circle because it is greater than, and we go to the greater side or through 0 because x 0 is greater than -12. For number 2, we need to divide both sides by -2. -2x divided by -2 is just x. 92 divided by -2 is -46. But because this -2 is negative, we need to turn that sign around. X is greater than or equal to -46. -46 is our key number. We're going to have a closed circle because it has the equal to, and where x is greater than -46, or on the same side as 0, that's the side we're going to shade in. For number 3, x minus 17 is less than -5, so we need to add 17 back to both sides. We get x then is less than, because for addition and subtraction, we don't ever worry about changing our sign around. We keep it that way. It's only for multiplying and dividing by negative numbers that our sign changes. -5 plus 17, these numbers have different signs. So if we start at 17 and add -5, we're getting closer to 0. 17 minus 5 is 12, and 17 is larger, so we're going to still be on the positive side of the number line. X is less than 12. Open circle because it's less than, and the less than side is to the left. For number 4, multiply both sides by 12 because x divided by 12 is greater than or equal to -3. That gives you x greater than or equal to -36. Notice that we don't change the sign because we are multiplying by a positive 12. It doesn't matter to us that the 3 is negative, although it matters in terms of the solution, but when we multiply in terms of which direction the sign is facing, that -3 does not affect the direction of the sign. So x is greater than or equal to -36. -36 is there. We are interested in greater than or equal to, so we fill in the circle to make sure we know that -36 is a possible part of the solution, and fill in the greater than side of the number line. For number 5, you need to subtract 17 from both sides to get x is less than 23. 40 minus 17 is 23. Again, drawing our number line, 23 is the number that we're interested in. Open circle because x is strictly less than. 23 is not part of this solution because 23 is not less than 23. It is less than or equal to itself. And an arrow in the lesser direction or through 0. 0 is less than 23. And finally, number 6, Multi-step one here for you to look at, but the process is exactly the same. We're going to subtract 4 first, although you can multiply by -2 if you want. Remember to change the sign, and remember that it needs to go multiply by -2 with the 4, the x over -2, and the 7. Everything gets multiplied. So we're going to take that away, get x over -2 is greater than 7 minus 4 is 3. Then we're going to multiply both sides by -2. Means we have to change the sign. X is less than, because we're multiplying by -2. X is less than -6. And on a number line, we'll make this bar here into a number line. -6. We're interested in only those numbers that are less than -6. Now let's go ahead and take a look at this problem. 4 plus x over -2 is greater than 7 if you wanted to do it by multiplying first. So 4 plus x over -2 is less than 7. If you wanted to multiply by -2 first, you could do that. It's a perfectly acceptable way of going about it. But if we think about this left-hand side, and I'll write it over here, 4 plus x over -2 as an entire thing, we are multiplying that entire set by -2. Now, this entire thing should remind us a lot about the distributive property, which is why we have to multiply all parts of it by -2. -2 times 4 and -2 times x over -2, because it is the entire side. This gives us -8 plus x. Notice that the sign doesn't change because -2 divided by -2 is 1. It just cancels itself out. So this is -8 plus x. 7 times -2 is -14. And because we are multiplying by a negative number, we need to turn that sign around to make it -8 plus x is greater than -14. Now, at this point, we have -8 plus x. We're going to subtract away a -8. Or, alternatively, if you keep change, add a +8. I'm just going to write it as a +8 over here, even though what we're really doing is subtracting a -8, but because of our subtraction rules, that becomes plus a positive. They represent the same thing. These two things cancel each other. We have x is greater than -14 plus 8, again on a number line starting at -14. Adding 8 means going back towards 0, but not quite getting there. 14 units away minus the 8 that we got closer gives us 6. 14 is the bigger absolute value, so we are still going to be negative. X is greater than -6, drawing that on a number line. X greater than -6. Now, I may have, indeed, wait, nope, I forgot to, I wrote the sign the wrong way. That's what happened. This sign started as a greater than 7, so we had this problem working on the opposite side. So the problem on the last page would have been, on the page there, would have been 4 plus x over -2 is greater than 7, which would have given you x is less than -6. This is 4 plus x over -2 is less than 7, so it gave us x is greater than -6. But as a quick review, when you're solving an inequality, you just solve it using the same rules as the equations. Remember that if you multiply or divide by a negative number, you need to flip the sign, because the absolute value directions flip on either side of the number line. And then to graph the number that x is being compared to, in this case -36. Use the open or closed circle to represent whether it includes or does not include that number, and shade in the direction of the solution.